Hey, welcome back to my channel. Today we're going to continue off of Friday's video. Hope everyone had a good weekend, by the way. Super nice weather. We had started to talk Friday about parabolas and quadratic formulas that were written in a different format, right? The first half of the chapter, all of our content, all of our equations and functions were written like this, where you had a certain number squared plus usually a number to the first power, and then we usually had just a number at the end. And we were able to use this axis of symmetry to find out kind of where it was located on the x and y axis. And then once we found the axis of symmetry, we plugged that number in to the function in the place of the x, worked it out, that told us the vertex, and then once we had the vertex, then we could just pick a couple numbers close to it and we could get our graph. That's what we did earlier in the chapter. This lesson, the one that we started Friday, was the second half of the chapter where the format of the equation of the function is written differently, right? You can see here we don't have ax squared. Now we have a and we have a parentheses. Nothing over here has parentheses in it. So whenever it's written like this with a parentheses and the x is part of a parentheses, we had to come up with a different game plan. And so our game plan involved just kind of understanding what each part of the equation does, right? And we talked about here the letter A. This letter A still adjusts how wide or how narrow the graph is, right? When the graph is going to have a letter A bigger than 1, it's going to be more narrow, like this one. If the letter A, the number right in front of the parentheses, is a fractional amount, an amount in between 0 and 1, or if it was negative, and in between 0 and negative 1, it's going to be more wide open. If the letter A is negative, this thing is going to be flipped upside down, something like this or like this. And then what we also started to look at is this number here called the H. I don't know why it's letter H, but it is. This letter H moves your graph to the right or the left on the coordinate plane. Well, let me adjust that so you can see it. So what we talked about Friday was it's always the opposite of the way that it looks right here because this has a negative in front of it. So minus 2 is actually going to be 2 to the right. Plus 1 is actually going to be 1 to the left. So it's kind of the opposite of the way you would expect. Most people, when they see plus 1, think, oh, that means 1 to the right. No. It's the opposite of the way that it looks. And so minus 2 is actually going to move it 2 to the right. Minus 4 would move it 4 to the right. And so this is one of the boards we looked at the other day. I don't want to spend a lot of time on it. I just kind of wanted to refresh your memory. We went through, oh geez, knocking my stuff over. On Friday, we went over this board where you can just look at the equation and tell some things about it, right? Here's my final answer from the very last one. The fact that it has a negative at the beginning tells me that it opens down. The axis of symmetry is always going to be this number right here, the opposite of this number right here, right? You can see how here, when it says plus 3, that actually means 3 to the left. And so that spot right there is at negative 3 on the x-axis. That's why I put x equals negative 3 as my axis of symmetry. The vertex is the same thing as the axis of symmetry. Negative 3, you just kind of drop it down. All you do is put a 0 after it. Negative 3, 0 is the spot right here where it reaches its highest point. And then if we compare that to the original graph, which starts in the middle, it opens up, kind of like this if I drew it on here. What I have done for this one is I've reflected it over the x-axis. That's what the negative does. The negative means it's a reflection and it opens down. I've made it wider, a vertical shrink by negative 2/5. That's what this number tells you. I've made it wider by a factor of 2/5. And there you go. We've also done a translation, a horizontal translation, 3 to the left. I didn't write that on there, but that would also have been the third thing that happened. So that's what we looked at the other day. So all of the boards that we looked at previously were in that form. Today, I want to kind of expand that. Let me kind of adjust this back. Sort of messed it up earlier. There we go. Into vertex form. So what we looked at on Friday was f of x or y. We had the a the other day. We had the parentheses. We had the x minus h squared. But we never had this, right? We never had a plus or minus something at the end of the equations, right? If I bring my board back from last week, look at all of these, right? After the parentheses and the squared, I'm done. I was putting red check marks over there because we were done with it. Today, look at the difference. Now we have a +1, a +3, a -2, a -3 at the end. That's okay. That is just one extra part that we need to interpret, but it's really not that harder than what we did on Friday. So hopefully this is going to be a pretty simple extension of what we did the other day. So basically what we can do is we can just add this last piece on here, and if we know what this represents, it's going to be simple. Okay. Basically what we've done. Okay, we know that this, the letter A, adjusts how wide or narrow, right? You look at the letter A to tell you if it's wide or if it's narrow. You also look at the letter A to tell you if it opens up or down. All right, if the letter A is positive, it opens up. If the letter A is negative, it opens down. Like, for example, this one right here is going to open down. This one right here is going to open down. That's what the letter A tells you. The letter H tells you how far you go to the right or the left, right, on the x-axis. Remember, it's always the opposite of the way that it looks. So this is going to be 2 to the right. -2 or -2 is actually 2 to the right. This one is actually going to be 1 to the left. +1 is going to be 1 to the left. And now what we're going to look at adding to it today is this right here, this letter K. This letter K at the end is going to tell you how far up or down. It's kind of like the y-intercept, you know? And so this is going to tell you how far it goes up or down on the y-axis. So like this one is going to go 2 to the right, and it's going to go up 1. So like if I did my little coordinate plane here, I'm just going to do a quick free-handed one. I know -2 means I need to go 2 to the right, but instead of staying right here on the x-axis, now I also have this +1 at the end. The +1 is going to be up 1. And so this graph is going to start right there at the point 2, 1. And then this is going to tell me that it opens up. This is going to tell me it's also twice as narrow. I'm going to freehand it here. But this is going to be pretty narrow, and it's going to look something like that. Okay? So this last number is going to tell you up or down. And it is very straightforward. It's not going to fool you. It is not the opposite of the way that it looks. +1 means up 1. +3 means up 3. -2 means down 2. And -3 means down 3. So this isn't tricky. This is not out there trying to fool you. This is very straightforward. Let me go ahead and get our kind of characteristics up here. We should be able to tell how these graphs open, up or down. We should be able to do the axis of symmetry. We're not actually going to graph these. I just want to show you how you can figure it out just by looking at it. We should be able to find the vertex just by looking at the equation. We should be able to compare it to the original one. Compare to the basic one, the most easy one that we can come up with, the one that's like this, right? Whoops, I messed that up. That should not be squared. Compare it to the original one. Oh, geez. Sorry about that. The original one, which is this, 1x squared. Okay? So how can we do this? Just by looking at it. Let's do another one. Well, actually, let's do this first one right here. H parentheses x, just like we talked about on my example a minute ago. I like to look at this part first. I don't know, it's just my own personal opinion. This means that if I do my little imaginary coordinate plane down here, that -2 means it's going to be 2 to the right. And I just talked about this a second ago, so this shouldn't be a surprise. I'm going to go 2 to the right. But now I also have to look here. This number, the +1 at the end, means I'm going to go up 1. So in the parentheses, the -2 tells me to go 2 to the right, because in the parentheses, it's the opposite of the way that you would think, right? -2 actually means 2 to the right. But then I'm not done right there. Then I need to look and see if there's something at the end, and we do. We have +1, so we're going to go up 1 right there. That is my vertex. I can actually do the vertex first. It's right there, 2, 1. That also means my axis of symmetry is x equals 2. The axis of symmetry is always going to be that. Right? The axis of symmetry is always the x-coordinate in your vertex, period. End of statement every single time. So I know that my axis of symmetry, right, kind of the midpoint of my parabola is going to be right straight up and down through that line at x equals 2. Now what I can do is go to the letter A, because I'm done with the H, I'm done with the K. I can come up here to the letter A. I see that it's a +2. That means it opens up, so I've got that. And then positive 2 means it's going to be twice as narrow. You saw me freehanded a minute ago. I just freehanded that. I didn't actually graph it for real. But what can that tell me? That can tell me that what we have is it's called a vertical stretch by a factor of 2, because we made it twice as narrow. That's what our book that's kind of how they will describe it. Now, we also did a horizontal translation 2 places to the right, right? We moved it 2 to the right. 2 to the right. And then we also now have a vertical translation, which we haven't had that before. We moved it up on this one, didn't we? That's what this number right here was telling us, to move it up 1. So we did a vertical translation. We did a slide, or I've seen some tests call it a shift. We've shifted it up 1. And that's kind of off my screen. Let me make a little adjustment there with my phone. And so I feel like in our book and in our textbook, even on like EOC tests, which I know we're not going to take this year, this is how they could possibly ask you, right? They could have you check all these boxes or fill out a little table with all this information. Just by looking at it, you don't even have to do the graph to get what we got. This tells you that it's going to be opening up because it's positive. This number right here is the opposite of the way that it looks. It's not negative. It's actually 2 to the right and up 1. That tells me the point 2, 1 is going to be my vertex. That also tells me the axis of symmetry is x equals 2. And then all those characteristics, if I just write them out in words, this is what it'll look like. Vertical stretch by a factor of 2. That's what this told us, right? That letter A always tells you the vertical stretch or a vertical shrink if it's less than 1. The 2 to the right is called a horizontal translation, 2 to the right. Moving it up 1 is called a vertical translation, up 1. Pretty simple once you get the hang of it. That first one is maybe a little confusing, but we're going to do the rest of them on this board, so it should have hopefully cleared up a little bit by the time we get to the bottom. All right, we've done the first one. Let's go right here to my g of x. So if I look at the g of x, I can tell right off the bat that this is going to be going plus 1 is actually 1 to the left. So if I make my little, I'm just going to do a little basic free-handed one down here just to kind of keep my brain on track. Plus 1 is actually 1 to the left. And then now what we have today is also this, plus 3. Now this one is just straightforward. The K is not out there to trick you. The one that's going to trick you is the H. See how it has a minus sign in front of it? So it's always the opposite. So this is 1 to the left, but the second part, the letter K, is not going to fool you. If it's plus 3, that means 3 up. So I'm going to go 1 to the left. I'm going to go 3 up, way up here. That is the point -1, 3. That is my vertex. And that is also my axis of symmetry, x equals -1, because these are always the same. My little dotted line, you don't have to draw it. Most people don't. I'm just putting it in there to kind of show you. Now I'm done with the H and the K. I can focus again right here on the letter A, right? The letter A. And that tells me, since it's a positive number, that it opens up. And the fact that it's less than 1, see how it's 1/2? That tells me that this thing is going to be kind of wide. And I could draw this. I'm going to try not to draw over my other one. This is going to be pretty wide. Much more wide than the one that I just did on the first example, but this one's going to be pretty wide. So now I can do my comparison. This is a vertical shrink. Notice on the last one I said stretch. Whenever your letter A is bigger than 1, whenever you make it more narrow, you call it a vertical shrink. Whenever this number, the letter A, is in between 0 and 1, or in between 0 and -1, like we'll see on the next one, it's called a vertical shrink because you're making it wider. When you make it wider, you call it a vertical shrink. You still put by a factor of 1/2. That doesn't change. So that tells you that we made it more wide. We kind of stretched this thing out. What we also did is we moved it to the left 1. So that's called a horizontal, I'm going to abbreviate, horizontal translation. 1 to the left. Or you could say left 1, 1 to the left. And we also moved it up. This is the part we didn't have on Friday. We also have a vertical translation. We've slid or we've shifted this thing up 3. That's what the plus 3 at the end tells us, right? And so each number kind of tells you its own story as it relates to the characteristics of the graph, right? This tells you vertical shrink by a factor of 1/2. This tells you moved 1 to the left, and the way we describe that is horizontal translation, 1 to the left. The number at the end is always going to tell you the vertical translation. If it's +3, that means up 3. If this would be a minus, like we're going to see on the next one, that one is going to get moved down. All right, we've got 2 more on this board, and I think we're doing all right. On the third one, I have I parentheses x right here, function I of x. It says -1/4, and then x minus 3 squared, and then minus 2. So this one's a little bit different than the last one. Let me go ahead and erase my graph so it doesn't confuse anybody. All right, I can tell you some things right off the bat, right? Just by looking here, I can see that it is negative. The fact that it's negative means that this one is going to open down. It's going to be a flip. It's going to be a reflection. I can look at the axis of symmetry and vertex, and I can get that here in a second as well. This number, -3, actually means 3 to the right. So I made it 3 to the right. But now I also need to look right here. This is -2. This means down 2. So I'm going to go 3 to the right, down 2, right here at the point 3, -2. That tells you your axis of symmetry, right? Your axis of symmetry is always the same as that number right there. So what I have on this one is a graph that's going to open down, and it's going to kind of go through that line right there. And I don't know if I'm really going to have a lot of room to graph that if it opens down. Let's go ahead and do our comparison, right? How do I do in my comparison? I go back. Look at this, -1/4. This is going to open down, and so I'm way out of room here. But this is going to be really wide because this number is less than 1. It's in between 0 and 1. It's going to be really wide, probably even wider than I was able to draw it right there because I ran out of room. And this thing is going to go really downhill, and it's going to be really wide. So how do I write that as my comparison? Okay, let's go back to the beginning. Whoa, the fact that it opens down, the fact that this is negative, the negative sign is called a reflection. Anytime it's negative, you have to put this reflection part. Reflection over the x-axis. That's important, over the x-axis. You can't just put reflection. You tell us what we flipped it over. We took the parabola that's normally pointing up, and we flipped it over the x-axis to make it go down. Okay? That's the negative sign. So I took care of the negative sign. What does the 1/4 tell me? The 1/4, okay, that number is in between 0 and 1. That means this is a vertical shrink, right? If it's in between 0 and 1, if it's a fractional amount, it's a vertical shrink, and then you just say by a factor of whatever the number is. And this one was 1/4. By a factor of 1/4. Okay, there's still 2 more answers. There's 4 pieces on this one. This number, the -3, tells me that we moved it 3 to the right. 3 to the right is called a horizontal, right? The horizon goes right and left. Horizontal translation, 3 to the right. And I'm out of room on my board, so I'll put it over here. The -2 at the end moves it up or down. Up or down is called vertical, right? And then it's also a vertical translation, down 2. So there were 4 different transformations, 4 different things that we did to this graph to change it. Remember the original one that we did way back at the beginning of the chapter that looked like that? It always sat right on the origin. Because look what we've done on this one. We've flipped it to change it from going up to go down. We've stretched it out, or done a shrink to make it wider. We've moved it 3 to the right and down 2. So we did 4 different types of transformations on that one. That's pretty confusing, but hopefully it made some sense. Okay, we have 1 more on this board. Let me kind of clear out all my scribbles here. And then hopefully we will be in a pretty good spot. I think I might have 1 more after this to actually graph one of them. All right, I've kind of got my red scribbles on there. Hopefully that doesn't mess you up. Let's go piece by piece and look at the equation. If you take it nice and easy, it'll tell you everything you need. Right here, the first thing I see is a negative sign. That's going to be my clue that it opens down. The -3, I'll deal with that in a minute. What I see right here in the middle, my letter H, this says +4, but remember, the part of the parentheses is always the opposite of the way that it looks. So +4 is actually 4 to the left. So this is going to be 4 to the left. So I'm going to maybe draw an arrow like that. 4 to the left. And then the -3 at the end, the -3 at the end is not going to trick you. It's straightforward. -3 means down 3. So I'm going to go 4 to the left. I'm going to go down 3. I'm going to be way down here at the point that is -4. negative 3. And that means my axis of symmetry is going to be at x equals negative 4, right? I could draw my little dividing line right through here, through the middle of it. And now I could try and graph this if I needed to. The fact that this is negative 3 means that it's going to be very narrow. And once again, I'm out of space. But this would be very, very close together. Something very, very tight. Something that almost looks like this, right? Maybe even closer together than that, but I ran out of room. Something like that. So how can I describe what happened? There's going to be 4 things that happen to this one as well, right? The negative sign tells me that it opens down. When it opens down, you have to say that it is a reflection over the x-axis, just like we did on the last one. Whenever you've got a number out here, you have to describe how much you've made it wider or narrower. When your number is like this, a number with an absolute value in between bigger than 1, all right? If it's bigger than 1, you call it a vertical stretch by a factor of 3. You don't have to say the negative. The negative is taken care of up here with our reflection terminology. So vertical stretch by a factor of 3, that means we made it 3 times closer together, more narrow. This right here, the plus 4 that told us to go 4 to the left, how do I describe 4 to the left? That's a horizontal translation. 4 to the left. And then the minus 3 at the end that told us to go down 3, that is a vertical translation. 3 down, and I'm about out of room again. So you can see each piece of the puzzle here, the negative sign, the number for the A, the number for the H, the number for the K, it all tells you a characteristic of the graph. Right? That's about as complicated as it gets, and I'm about at the 20-minute mark, so let me move ahead to my last board. I hope this is the last one. Yes, it is. I don't know how often that you'll actually have to graph one of these, but if they do ask you to graph one, here you go. I made one for us just to try. I don't know if we'll have to graph one on the assignment or not. I can't remember. So if you do actually have to graph one, all those things that we just did on the last 4 questions, the 4 examples, those are going to be great characteristics to still continue whenever you have to graph one. Okay, if I actually have to graph one, I've got my graph set up, I'm ready to go. Where do I start, right? Do I just go ahead and make an X and Y table and start filling out numbers? No, not really. Let's just think about it using the same skills that we did on the last ones. Okay, this number is positive. I'm just going to make some notes to myself. When that's positive, that tells me this thing is going to open up. Whoa, hit my camera. So I know that this thing is going to open up. I also know that this letter H right here, this tells me something, right? Minus 2 actually means 2 to the right. So I'm going to be kind of sitting over here, 2 to the right. But now my letter K right here, my letter K is going to tell me how many to go up or down. So this means 2 to the right. This means up 1. 2 to the right, up 1, right here. So I've got my vertex at 2, 1. That also can get me my axis of symmetry if I really needed it. I'll go ahead and put this dotted line in here, and then I'll erase it whenever we're done. So I have the axis of symmetry at x equals 2. And now I know that this number at the beginning, the letter A number right here, my number 2, see how this is in the same spot as the letter A right there, right in front of the parentheses? This is telling me that my graph is going to open up because it's positive, and it's also telling me that it's going to be twice as narrow. This thing is going to be pretty narrow compared to the original one. So how do I know how narrow to make it? Do I just freehand it? No. What I need to do is now I can actually do an X and Y table, but now I have a good idea of where I should start, right? I know that the point 2, 1 is going to be on my graph because I just did it. So what I want to do is I want to pick some numbers that are close to the number 2. So how about if I pick 1 or if I pick 3, it doesn't matter. You see how they're both one place away? Well, this is just 1 to the left and this is 1 to the right. They're going to have the same answer because it's going to be a reflection of itself. So let's pick the number that's easier. I think 1 is easier than the number 3. So let's take the number 1, and remember, here's our equation. Let me just write it again down here since I kind of put all those circles up there. If I put the number 1 down here into this problem, the number 1 would go right there. I would have, let's see, 1 minus 2 would be negative 1, right? If I take the number 1 and substitute it right here, you would get 1 minus 2. 1 minus 2 is negative 1 squared. And then I could just work this out. Remember, order of operations says you have to do the parentheses first, not the multiplying first, parentheses first, the exponents first, right? Sorry, the exponents is what I should have been saying there. Negative 1 times negative 1 is 1. So I have 2 times 1, that's 2. 2 plus 1 is, this answer is 2, right? 2 plus 1 is 3. And so 1 is going to have a corresponding y point of 3. 1, 3. And the number 3 is also going to be up there. Because see how this is just going to get flipped over? Since this is one place to the left of my axis of symmetry, and this is one place to the right, it's going to be at the same height. So there is that point. I can also do one more, maybe just to make it look a little more official. To be honest, I could probably make my graph right now and it would be fine. But I want to try to make it look even better. I could pick the number 4, or I could pick the number 0, whichever one is easier. Probably the number 0 is easier to do than the number 4 because they're going to be the same. See how the number 0 is 2 places to the left of my axis of symmetry, and the number 4 is 2 places to the right. It's the same distance, and so I really only need to do one of the problems because it's going to be a reflection like these two are a reflection of each other. So let's do 0 because 0 is a little bit easier, I think, than 4, although maybe this one, 4, might have actually been easier. Whatever. If I put 0 in here, I'm going to have 2 times 0 minus 2 squared plus 1. Okay, 0 minus 2, that's negative 2. Negative 2 squared means negative 2 times negative 2, that's 4. 2 times 4 plus 1. Okay, 2 times 4 is 8. 8 plus 1 is 9. So 0 is going to match up with 9. If I would have put 4 in here, I should have had the same answer, right? Just for fun, if I had put 4 in here, it would have been 4 minus 2. That would have been 2. I would have had 2 squared times 2 plus 1, right? 2 squared is 4. 2 times 4, 8 plus 1. It would have been the same thing, right? 8 plus 1 is 9. And so 0, 9, and 4, 9, all the way up here. And at the number 4, all the way up there. And now I can probably make my graph. It's going to be pointing up. It's going to be shifted. Whoa. To be honest, you really don't want this axis of symmetry probably on your final answer. And so if you have the ability to erase it, like I can obviously just do that with my finger, this is the best way to make it look. Right? Now, I'm not going to make you describe this one with words, but if I wanted to have a description of this one, right, what words would I use to describe this one? I would go back and I would say, okay, because this number is bigger than 1, we have a vertical stretch by a factor of 2, right? Vertical stretch, that means it's twice as narrow by a factor of 2. The fact that we moved it 2 to the right and up 1, that's something I need to describe, right? 2 to the right means it's a horizontal translation. 2 to the right. And then we also moved it up 1 because of this right here. This is a vertical translation up 2, right? And that's it. We made it twice as narrow. We moved it 2 to the right. We moved it up 1, and that's what we did compared to the original one. Remember that original one always sits like kind of right here, and it's on the origin, and it's a little bit wider than the one that we just did. And so that's it, guys. I'm going to go ahead and put some questions on Big Ideas Math. I would love it if you have a chance to try them out. And thank you so much for watching. You can use this video to help you answer the questions as you go. And I will catch you guys in a video very shortly. Have a good one.